Hello again, Professor Zawolo. Today I'm going to be going over the algebraic expressions section of the West African Examination Council Senior High School Certificate Examination Mathematics for Liberian Schools. Under subsection B, algebraic processes, I will be going over section H, algebraic fractions. First thing we're going to learn to do, the first objective we're going to address, will be performing operations on algebraic fractions with monomial denominators. So let's get some background information on what is an algebraic fraction and what makes it a fraction with a monomial denominator. So an algebraic fraction is a fraction containing variables. We can add, subtract, multiply, divide, or even just simplify algebraic fractions. Just like when we do fractions of whole numbers or fractions, we deal with in arithmetic. We have to find the least common denominator when we add and subtract. We have to cancel common factors when we multiply. And for division, we have to multiply by the reciprocal. All of those rules are going to be applicable to algebraic fractions. An algebraic fraction is in the simplest form when there is no common factors between the numerator and the denominator. And why do we call it a monomial denominator? Because the denominator has one term. So we're going to go over several problems. We're going to begin with problems involving division, multiplication, addition, and subtraction, and then we'll do problems that will put all of those concepts together. So let's see. So in problem number 1, we have to multiply these two algebraic fractions. They are algebraic fractions because they contain variables and they're fractions. So what we want to do is to use the law of indices as well as the laws of multiplying whole numbers to get our answers. So how does this work in this case? So we have 3x squared y over 20z times 5x to the 9th over y to the 4th x to the 5th. Now, one of the things I'm going to do, I'm going to restructure them like this. So I'm going to do 3. On top, I have the whole number 3 and 5 as a product. On the bottom, I just have 20. Then I see some x terms. On top, I have x squared and x to the 9th. And at the bottom, I have an x to the 5th. So I want to do it like this. Then I see terms, I see y's. I see the variable y. I have a y on top. And I can just put 1 to indicate it's the power of 1. And I see y to the 4th at the bottom. I see a z. Interestingly, I do not see a z as a numerator, but in the denominator, I see a z. So I can write it like this. So then I have to simplify this first fraction here, which is basically 15 over what? 20. And for here, I'm going to use the laws of exponents, so of indices. So to multiply two indices with the same base, I add the power. So the 9 plus 2 is going to give me 11. I have the 11x over 5. And the same thing I'm going to do here. I'm going to have y to the 1 over y to the 4th. And then I'm going to have 1 over z. So let's see. When I simplify 15 over 20, I can divide this by 5 and get a 3. Divide this by 5 and get a 4. So basically, for that part, I have a 3 over 4. And then I can subtract the powers over here because this is division of indices. We subtract the powers. 11 minus 5 would be 6 is positive, so it stays up. That's positive 6. And then I have 1 minus 4, and that's going to be a negative 3. So for now, I'm going to put y minus 3. And then I have a z that is just down. There's no z up. I'm going to keep it like this. Now, you know that we have to write our result using only positive exponents. So we have to change the position of the negative exponent using the laws of negative exponents. We're going to bring that down I'm sorry, x to the 6 x to the 6, and then I have y to the third down, and z. Do that again. X to the 6 over 4y to the third z. That's basically what we do. Okay? Let's try another example. Now we have to divide. So we need to remember that when we divide fractions, we multiply by the reciprocal. So we have to change this to multiplication first. We do 81 over PQ times the reciprocal of the second first. VP, the third over Q over 27. And moving over to the right, we're going to do the same thing we did. So I see whole numbers. I have 81 on top and 27 at the bottom. I have P on top, which is P to the third, and P to the first power at the bottom. Then I have Q on top, and I have another Q at the bottom. So clearly we see that the Q's will cancel. 81 divided by 27 is 3. And then I have 3 minus 1 because I'm dividing here, so it's going to be 3p squared. Simple, easy, basic. Let's move on. So we've done two problems, one on multiplying, another one on dividing. So basically, the only way we can add fractions is that the fraction must be written using the same denominator. Looking at the three denominators we have here of 4, 6, and 12, we see that our LCD is going to be 12. So we must rewrite each problem here with the same denominator of 12. 12 plus 12 plus 12. So how do we figure this out? So basically we can say 12 divided by this 4 is 3. So we're going to multiply the numerator by 3. 12 divided by this 6 is 2. We'll multiply the numerator of n by 2. And 12 divided by 12 is 1, so we just multiply the numerator over there by 1, so we have 7n. So now we have, on top we have 15n plus 2n plus 7n over what? 12. Because here we just have to add the numerators and keep the denominator. So we have 15 plus 2 is 17. 17 plus 7 gave us 24, and divided by 12. And when we divide this, our answer is going to be when we divide this, our answer is just going to be 2n. And so now we are done. Let's take on another example. Now we have to subtract. Subtraction involves the same thing. We must find the least common denominator. However, here it's a little bit more complicated. So we have to find the least common denominator of 3 and 4. And we must also find the least common denominator of what? Y and y cubed. So what is going to be common to both terms? So the least common denominator for 3 and 4 would be 12. The least common denominator for variable powers would just be the highest exponential power. So in that case, it would be y to the third. So putting it together, our LCD here would be 12y cubed. So I'm going to rewrite our problem with the same denominator. So instead of 1 over 3y, I'm going to write 12y cubed here for now. And minus, I'm going to put the 5 there for now. I'm going to put a multiplication sign. You're going to understand why shortly. I'll do 12y cubed. Now, I have to think, Here was my denominator of 3y. Now it is 12y cubed. How did I get that? I multiply by something. How do I find out? I will divide 12 by 3 to have 4, and I will divide y cubed by y, which is subtracting, and that will give me y squared. Same thing. I had a denominator of 4, now I have a 12. So what do I do? 12 divided by 4 is 3. If I do y cubed divided by y cubed is 1, so does it make sense to do anything? So over here now I have 1 times 4 times y squared. That would be 4y squared minus 15 all over the same denominator, which is 2y cubed. Can we do something here? Well, perhaps we can maybe factor out, well, not really, we can't do anything. We cannot factor out anything from here. So that's basically going to be our answer, right? Let's try another one. Now, for this problem, we have both subtraction and division. So let's do first things first. We have division in the bracket, so let's do that first. We have subtraction in the bracket, so let's do that first. So we have 3x minus 15 over what? 2y. Now we see that our denominators are unlike, they are different, they have no common factor. So the LCD for our denominator of x and 2y will just be the product of those two. It will be 2x, 2y times x, which is basically the same as 2xy. So now we must rewrite our fraction using that denominator. So now, for now, the numerator is 3. We've changed this to 2xy minus, we're using the common denominator of 2xy, and the numerator was 15. Now, so let's go and do the same thing again. 2xy divided by x will give us 2y. Now, we're going to do the same thing. 2 and 2 will give us, divided will give us 1. Y and y, when we divide, is going to give us 1. So we're going to be left with just x. So we'll multiply here by x. So for now, what do we have? We have a common denominator of 2xy and a numerator of 2 times 3 is 6y minus 5x. Now, we have unlike terms in our numerator, so we cannot subtract them. There's nothing we can do about them. But now we have to divide by 6 over xy. And by rule, when we divide fractions, we multiply by the reciprocal and cancel common factors. So we'll be multiplying by xy over 6. So let's see what happens here. xy is going to cancel. So what do we have left there? It's going to be basically 6y minus 5x over, at the bottom we have 2 times 6 is 12. That's all we can do about this. Let's take on another example. So again, here we have addition and then we have multiplication. So we have to do the bracket first. In the bracket we have addition. Well, we can easily see that our LCD will just be the product of 3x and y, which is basically 3xy. So we can write our bracket term using the same denominator, 3xy plus 3xy. And as we practice this, as we see what's happening here, we get to do a little faster. So the denominator was x. Now it's 3xy. That means it's changed by the factor of 3y. I will say x and x will cancel. We'll be left with 3y. We multiply 3y by 4. So it's 3y times 4 plus. I have a 3 and 3 in agreement, y and y. So basically, left over will be x. So I multiply x by numerator. So I have 12 times x. And we're going to be multiplying this by xy over 16. So let's go over here. We can add, we write the product as 12y plus 12x over 3xy times xy over 16. Now we see that on top, we can do some factoring. 12 is common. We can take out 12. I'm going to just write that as x plus y. I could do y plus x. That's fine. And then I have 3xy over here times xy over what? 16. Now I see that I have xy at the bottom here. Xy at the top will cancel. I also see that I can do some cancellation over here. But let me do this. Let me do 12 on top over 3 times 16. And then on top, I have x plus y and then 1. So I can do some cancellation over here. I can divide 3 by itself 1 time, 3 into 12 4 times, 4 into itself 1 time, 4 into 16 4 times. So for my answer, in the numerator I'm left with x plus y, and in my denominator I'm left with 4 times 1, that's 4. And I'm done. So basically, we've gone over adding, subtracting, multiplying, dividing, and doing a combination of adding, subtracting, and multiplying algebraic fractions with monomial denominator. Thank you.